simple, and keep on adding into your model to make it a working part of the software. So the first thing that Agile principle says, assume simplicity. See, normally creating a simple system is the toughest work. How many agrees with me? Okay, I think majority of the people, creating a simple thing is the toughest part. So it says, unless you create a simple model, you cannot enhance it. So the first principle says, the model should be simple. Embrace the changes. Open for any change. Don't think that whatever model you have created is the best one and there is no scope of improvement. If any of your team members suggests, and if it is feasible, viable, welcome the change and make that change into your model. Enabling the next effort is your secondary goal. See, most of the time what happens with developers or testers, while doing their current work, they always think about the next work. Agile model says, stop thinking what you want to do into next iteration or next thing. Please concentrate on the work in hand. So enabling anything which will come after some time is your secondary effort, and don't give emphasis on its secondary thing. Making sure whatever you are listening, whatever you are thinking, whatever you are doing, you are fully concentrating on a single work at a single point in time. Then increment changes. It's like Agile. Keep doing iterations and iterations of your design. So first start with the simple design, make an iteration, make it more, keep it better and better, so that finally you will get the best solution out of that. Multiple model with a purpose. Whenever you are creating a model, don't think that you have to create a model, you have to create something. No, that model must have some purpose. So if your model is not solving or is addressing to a purpose, it's not a model. So take a case, if you have to create a model of this hotel, then create a model depicting the interior parts or outer exterior parts of this hotel. Or when you are creating a model of your system, think that how you are going to explain this model to your customer. So that will solve a particular purpose. Then multiple models, don't stick to a single model. May possible, different model with different aspect, with different view may have an advantage over the other model. So Agile modeling always says, don't create a single model and stick to that. So normally the team members, different team members, they will come up with different models and they discuss about those models, and the best is taken into consideration. Maximize stakeholder involvement. Whenever you are creating a model, whenever you are discussing about the model, ask your stakeholder to present in the room or present in the meeting, because ultimately we are developing software for whom? For the stakeholders. We are going to get money from them, and if they are not satisfied, all your effort, all your modeling, or your Agile or your waterfall is waste. Then have a quality work and rapid feedback. Rapid feedback means, if you have created a small model, go and check with your customer, get a feedback. Go and check with your team members, get their feedback whether you are on the right track or not, whether this is going to solve the problem or not. And then software is your primary goal. Whatever you are doing, the working software is your primary goal. All quality, all price, all estimates, all planning is a waste if your software is not working. Normally what happens in our software life cycle, we first start thinking about quality and process without thinking about a working software. That is where the manifesto of Agile says working software is more important, rather it is the most important thing. You have done Six Sigma, you have done CMM level 5, but the software is not working. It's a waste. Today we have seen the presentation got abruptly disturbed 5 times. It means there is a problem with the software. Whatever company that has developed as the #1 company in the world, but if it is not working, it's not worthy. And the last point that AM principle says, travel light. Any blind guesses what exactly is travel light? Fast. Another answer? Okay, minimum set of things to achieve your purpose. Any other answers? Okay. Any other? Okay. So we all tried to answer the question by looking at the word. Fine. If you look at agile modeling, the travel light word means don't write big document, because documentation is one thing that we need to carry throughout the project. I remember earlier we used to write functional spec, requirement spec, low level design, high level design, but the people who used to code, they never gone through those documents. They said, no need to write big document, no need to write comprehensive document. Don't get me wrong by understanding no documentation. So I tell you, there are two methods of doing documentation also in Agile. One of the method is known as scenario focused engineering. Anybody heard about SFE? Okay, SFE is a very new thing which is coming into Agile world. It talks about documenting supported by a picture. And this picture is not your DFD, this picture is not your Swimlane diagram, and this picture is not anything else. It is just a simple comics kind of thing, where you will see what exactly actors are doing, what exactly is the system flowing, and this process is known as scenario focused engineering, SFE, coming very fastly. And the another process is feature driven development, where you have to answer 3 questions of each requirement. If, when, if, then when. So all your requirement will answer just 3 questions. Take a scenario, answer these 3 questions, your documentation is done. Fine. It's not the time to discuss those things, but you can Google about these things later on. And what are the core practices for Agile modeling? Active stakeholder participation is very important unless your stakeholders are not participating. And remember, while doing Agile modeling, your stakeholders are your team members also. They are not the higher management or the customers or the clients. It's your team members also. So everybody is equally important to participate while creating a model. Apply the right artifacts. In Agile modeling, we have artifacts in terms of our testing documents. So we start with unit testing, functional testing, integration testing, system testing is and all. So at each different level of your model, you should apply the correct artifact. Collective ownership. Once the design is created and finalized, the entire team owns the design or owns the model. Even if something goes wrong with the model, no specific person will be blamed, or no specific person will be rewarded. It's a collective ownership of the team. Create several models in parallel. Create simple content. Depict model, simplify. So you don't have to create a single model. Keep 2-3 models ready. Display it to the customer, display it to your team members, and let them decide which one is the best. See, normally this we do with while we go to purchase clothes and all. We go and try too many things. We ask our friends, we ask our wife whether I am looking good into this or not. At the moment I get an answer, okay, you are looking very nice into this, we purchase. The same thing we are doing into Agile also. We create many models, simple models. We display it to the customer, we display it to all the team members, and the best one we are selecting. Iterate to another artifact, model in small. It's a prototype. And in my coming slides, I will tell you how these prototypes are getting bigger and bigger. One more important aspect is, yeah, please. Yeah. So I'll answer your question in my coming slide, where you will understand what exactly I'm talking about, how to create a model, what a model should contain. One important aspect of core practices is proof with code. You just don't have to create a model. You should be ready with the code also. And this kind of practice is known as proof of concepting, POC. So you just don't have to create a model. May possibly you create a very flashy model which is not feasible to code, or you don't have people to write the code for those kind of models. So the responsibility lies with the person who is modeling it to come up with the code also. The code may be just a proof of concept, just a small code saying that, okay, this is possible, or this is how, these are the functions, or this is how you can achieve this. So while creating a model, you have to make it simple, and you have to come up with the code also supporting your model. So these are main principles and practices of agile modeling. An agile model says, if you are applying agile modeling to your project, you have to adopt all the principles and practices. Then only it is going to, solve your problems. Okay, now we got a question from the friend, what exactly are these models? Are they prototypes? I will little deviate from your question. Actually, these are not prototypes. Now with these kinds of model, I will explain you how we take a requirement and how we create models and prototypes and codes. Fine. So in agile modeling, we have 6 types of model. The first one is known as architectural envisioning. When the project starts, you got hundreds of requirements. Now how to start the work? Then at the very beginning level, they said you have to come up with architectural envisioning. Now architectural envisioning is a prototype of the entire system. Not too much detail, but somehow depicting the entire requirement. So this is a model having a prototyping of the entire system. Creating this architectural envisioning, it takes days. So normally if you are applying Scrum, if you are using Scrum in your project, then normally it will go into which sprint? It will be part of sprint 0, where you will take 2 days, 4 days or 5 days to create an architecture of the entire system. The next level of model is known as iteration modeling. So now you have a big prototype, correct? At the very first level, sprint 0, you created the prototype of the system. At the second level, when your sprint starts, you went through the sprint planning meeting and you created a sprint backlog. Now iteration modeling says you have to create another model just to suffice the requirement of this is another set of requirement. Probably you can map these models to low level designing or the architectural envisioning as high level designing. So at second level, when you have to model it, it will be low level of design of the entire sprint backlog that you have decided in your sprint. Now how you have to design this? You have to design your your iterative modeling, making sure that it complies with the architectural envisioning model. So now you have two models. First model at the higher level. When you are creating a second model, this is more a kind of sub part of this entire system. Now from iterative modeling, you have to start focusing on coding part of the system. And the first part we just said what I need. Now from here it will start talking about how I need, what are the algorithms that I'll apply. So if you look at from here, The first one was just your prototype. The second one will be your proof of concept kind of thing, where you will come with small code stating that this algorithm I am going to apply. Then at the third level is model storming. Now when we will do iteration modeling, so you did your sprint planning meeting. Once the sprint planning meeting is over, you can spend some hours on doing iteration modeling, and once your iteration model is ready, again you have to break your iteration models into something called model storming. In model storming, what we do is a just-in-time kind of model, where we take one requirement. We just take one requirement, we create a model for just that particular requirement, and I will come and present in front of all my team members, and I will get their opinion. So, architectural modeling of the entire product backlog, iteration modeling for the sprint backlog, model storming is the model just for a single requirement. So take a case today, you want to start with user story 1. So you will create a model and you will go with the model storming. Day after tomorrow, your another team member will start development work for another user story. So day after tomorrow, he or she will present another model with the team, making sure that each model are compliant with the previous model. It should not go away either from your architectural model or from your iterative model. So once this model storming is done, people will say that no, this algorithm is not going to work, or this algorithm will be better, or if you use for loop or while loop, it will be better here. So these kind of discussion will happen, and you will get a clear-cut idea to how to go with your coding. So that is the third level of modeling. Then the fourth level of modeling says test first design. So you have come up with a small code, and it says just do enough code to pass one test case. No, don't write the entire code and apply your testing. Just write enough code, apply your test case, and if it is passing, then start coding to another test case, and keep on refactoring of your code. So that take a small snippet of the code and look at how that particular part of the code can be improved to pass the next test case. And taking together these things, taking together test first design and refactoring, a new method has come into Agile that is known as TDD. Any idea about TDD? Test driven development, correct. And actually when we club together this refactoring and model storming, this is known as TFD, test first design. First test your design, and if your design is passing, then only write more code to pass the next test case. So if you look at TDD, they never talk about the designing part. They always talk about how to pass the unit test cases. So one step further of TDD is known as TFD, test first design. First test your design, because if there are flaws in the design, the entire system is not going to work. So it is one step further ahead of TDD. TFD still is very new into Agile world, but it is coming very strongly. And then you have the last level of designing or modeling, that is known as continuous integration. So keep continuing integrating your code. So at the very first level, when we did the architectural envisioning, and at the last stage is the continuous integration. So we start with a model, second step become a POC, third step we did the storming of the model, fourth stage we just written enough code to pass one test case, and the fifth level we have the continuous integration. So whatever we started from the concept, we come up with the code, and this is a working code owned by the entire team. And so the principle of Scrum, which says within a sprint you have to take a requirement and you have to come up with a working code, can be achieved through agile modeling. Have I answered your question? Just a minute. Okay, fine. So then let me come to the next slide. So when I am talking about model, there are no specific models which says it could be different model for this project, different model for that project. The only thing that you have to come with, at the first level you could have some model, it could be your high level design, but at the second level it must be supported by proof of concept, POC code, and that must be a working kind of POC. It should not be, okay, this is not working this time, tomorrow it will work. No. Yes.
Incurred in that project if I start introducing this kind of models wherein the first code is written which can be tested initially, then I go ahead with the testing. I mean, it becomes somewhat difficult to estimate the cost, I feel. Indirectly, it adds up to a very good product, I understand that. I mean, even we are thinking in our project of a similar proposal wherein when people develop a proof of concept and the actual developers just don't even aware that there is a proof of concept. They start developing from the scratch. So we are also proposing a plan wherein proof of concept code has to be used from the initial day of development when it is done with a purpose. I completely agree with your idea, but only problem is it gets difficult for a manager to estimate the cost.
Okay, so costing was one part. Now, do you know how much a percentage of the cost of any project we incur during testing phase? Is almost 60% of the cost. Now, why these things came into the picture? Nowadays, testing is such a costly affair that everybody wants to avoid finding more and more bugs in the testing phase. What was happening earlier? We got a requirement,